Good evening. In previous session, we have seen the concept of generators. So today we are going to see the uses of generators. So in yesterday's session, we have seen about how to create a generator, how to uh, get the elements from the generator object we have seen. So now in today's session, we are seeing the uses of generator. So first one is, as we have seen in our previous example, first one, easy to implement. Easy to implement. So whenever we are seeing about generator functions, their first thing we have to understand is, first one, if we are going to write any function, in that function, if we are using a yield method, then that function is called as a generator function. So how to call the how to use the data of the generator object means, for example, let us take func. Here I am going to write, so I have to use a next method. So whenever you are going to use the concept of generator functions, there we have to use two things mainly. One is yield function, yield keyword. Next one is next function. So these two has to be done. So this concept was discussed in previous session. So anyway, it is easy to implement. So already in previous session we have seen the disadvantages of return also. So return is having some disadvantages, so yield is having some advantages. We have seen this concept. Anyway, next second point is memory utilization is very high. Memory utilization is very high, or high we can consider. So this concept I will explain with a small example, so that you will get some idea on this memory utilization. So just I will take a small example. So here I am going to consider one list. In this list I am going to store some values. I want to perform some operation in that, that is x into x. Already we know the concept of list comprehension. So here I am going to write for x in range of, I will take some data. Otherwise first I will take small data and I will show you the output, what we are going to get. So here I am going to write list of 0. Here what I am doing, I am going to take how many values, range of 100 means it is going to take from 0 to 99. I want to perform that is x square, that is x into x is nothing but x square. I want to perform the square of that particular number and I want to store in the list. That means 99 squares will be there in our list. So I want to print only first value. That is what 0 square will be printed here. Just I want to show you the output first now. So we are going to get output as 0. But now what is our concept, what we are seeing here? I want to show that generator, by using the concept of generator object, the memory utilization is high. I want to show. That means in this case, I want to show you the disadvantage. So here I will not take only 100. I will take a large value. For example, I will take 10,000 or 1 lakh I will take. So let us see 1 minute. Okay. Now see here, we are going to get value, no problem. But if I am taking here some large value, okay, and I'm saving it. Now observe this, what we are going to get as an output. Here we are going to get a output that is an error saying memory error. So just I will say why it is going to give a memory error. Okay, let us see what it is going to give. It will take some time. 1 minute. Now see what we got here, memory error. So what is meant by this memory error means, observe carefully here. Here what is going to be happen means, I want to store how many values I am going to store here, from 0 to 99999. So here 1 2 3 4 5 6 7 8 9 are there. So 1 2 3 4 5 6 7 8. So up to here it is going to take the number and it is going to perform some square operation on that number and it is going to store in a list. Here the concept is, whenever you are going to create some object in runtime, it is going to allocate some memory. Whenever we are going to execute a Python program, for that program dynamically some memory will be allocated. If further here I am going to create an object called as list, for that some maximum memory is going to be allocated. So if we go on increasing the number of values in storing that list, what happens? The size is going to be exhausted. That means what? It is whose problem? It is our computer problem. For example, I'm going to take here we are having a RAM called as 4 GB, for example. Some it is going for OS, okay, and some remaining programs. I'm using GoToMeeting, so here some memory is for GoToMeeting, and I'm also using some Paint. Some memory is for Paint, and here I'm using what some Python program I am going to execute. So in this Python program, what I'm doing, I'm going to enter a large data set. So what happens? The memory that is allocated for this Python may not sufficient to store these values. Then what happens automatically? Here the memory is going to be filled. Our memory, external memory is going to be filled, so that the values what we are going to give for the list cannot be stored. So we are going to get what? Memory error. There is no problem in our program. In our program, syntactically or logically, our program is correct. But to store those values externally, I am not having the memory. So that we are going to get what? Memory error. That means what? If you are going to give a large data to be stored, then what happens here? We are going to get a memory error. But now I am going to show you the concept of same thing by using the concept of generators. Okay, there I will not get any error. So let us see, so that you can understand what is the advantage of our generator. Same thing I am going to take, but here just I will change it as I am using generators, I will change it as a G. Just I will change it as, okay, parenthesis. If I am going to write a comprehension within a parenthesis, that indicates what? It is not indicating tuple, it indicates a generator object. So if you want to see that, so see here, if you want to see the type of object, okay, later I will show you. Anyway, first I will show you that, so that you will get a clarity on that. Okay, now see, I want to print the type of G. If I'm going to print type of G, what we are going to get? Generally, we may think that it is a tuple comprehension, but it is not a tuple comprehension. For tuple, we cannot have the concept of tuple comprehension. So see, we are going to get output as what? Generator object we are going to get. Okay, 1 minute. Sorry. Here I am going to write some, this is not present, so we got some error. So see what we got, it is of type class generator. Okay, it is not a tuple. So now I am going to store the values, some up to whatever the values we have taken before, that is some, so on I'm going to take. Generally what we have to get in previous program, what we got, I got an memory error. See here, we can observe clearly, I have taken how many values? 1 2 3 4 5 6 7 8 9. But here I will take 1 2 3 4 5 6 7 8 9 10 11 12 13, and I will execute this program. So now you may think that what, again we will get the error, you may think, but we are not going to get any error here. You can observe that clearly. Just I want to print what? Next of G. Already I told you, to retrieve the values from a generator object, we have to use what? Next function. So now what is going to be happen? First, listen carefully. Before going to execute this one, I will explain internally what is going to be happen. So whenever I am going to write this expression, first what happens means, first value, that is what, 0 will be considered, that is x into x, that is or that will be stored in G. Whenever I am calling next of G, it will give me what? 0. That means what, it is not going to store that value, it is going to send me here. Again, if I write print of next of G, again next value is what? 1. 1 into 1 is what? 1. Next 2. Next is what? 3. That is what? 3 into 3 9, and so on. It is going to print. It is not going to store any values. But in before concept, what happened? I am going to write a list comprehension, and I am going to store in some list, some L or any name we can take here. So here what I'm doing, all the values will be stored in list. If I print list as an output, all the values will be printed. But in the concept of this generator, what happens? It is not going to store all the values. Whatever the value, it is going to first it is going to take one value and it is going to send it. Next it is going to take one value, it is going to print. Next it is going to take third value and it is going to print. In this way, the operation is going to be executed in our generators. So now what should be happen? You may think that we will get the memory error, but here we are not going to get any memory error. Let us see. Okay, see here what we got answer 0. That means the same program before what I have taken only 9 zeros, total of 9 elements I have taken, but we are getting memory error. But here I am taking some large value than whatever we have taken before. Okay, that means what here in generator concept, whenever we want to store a large number of values, better use the concept of generator. If you are using any list type, the size may be what it cannot store many values. In the concept of generator, I am not storing all the values in the same variable. At a time it will store one value, and whenever I am going to all next object, it is going to print, and so on. Okay, this is the concept of generator. In our generator, memory utilization is high. What is meant by memory utilization is high? For example, here if I am going to store some 100 elements in a list, so let us consider L here. I have taken some 100 here. Okay, so here in this I am going to get what 0 squares I am doing. So here I am going to get 4, 9, 16, 25, and so on. It is going to store. After that, we are going to use this L. Okay, after storing all the values, if I write L of 0, I am going to get output as 0. But in the concept of generator, what happens? Before, it will not store all the values. One at a time it is going to store, and whenever we are going to call next of g, it is going to give the output of first value. Next, if you write next of g, second time I am asking, so it is going to give me second, and so on. Okay, so that execution speed also will be high, and also the storage means what? Here at a time one element only it is going to store. That means, for example, some memory location is there. First value it is going to store 0. Next value it is going to store 1. Next value it is going to store some 4. Next value 9, and so on. But here what happens? How many memory locations we require here? It is going to require nearly 100. For example, I am going to take 100. So it requires 100 memory locations. If I use one location multiple times, then we can say I'm going to utilize that memory very high. It is nothing but a small example I will take. I am going to buy one small ball, cricket ball. So if I keep it in my house and if I do a puja for that, will there be any use of that? No. For what I am going to buy this ball? For playing. Okay. So for playing I am going to buy. That means if I utilize this one high, then I can call this one as what? I am utilizing the ball high. Ball utilization is high. In the same way, if I am going to take one memory location, and if I am using regularly only that memory location only, I am utilizing this memory very highly. Utilization is high. But if I am considering here, what happens? For 0, one memory location, for 1, second memory location, for 4, another memory locations. Here, how many memory locations we require? 100 memory locations we require. That means here, I am not utilizing the memory high. For here, one location is used for 100 values, for example. Here, one location is used for only one memory, one value. Here, this is for 0, this is for 1, this is for 4, this is for 16, and so on. So that we can say by using the concept of generators, memory utilization is high. Okay. In the same, if you are going to consider for a function, a normal function return, if I'm talking about return also, return what it is going to do? It has to store a sequence of elements after going to store all the elements. So anyway, we have seen this example. Yield, what happens? Yield at a time it is going to send only once, one element. After that, second element. After that, third element, and so on. How many elements are present in that generator object? It will send one by one, so that there will be no concept of memory error if you store huge amount of data also. Okay, this is second point. Now I want to show you a third point which is very important. That is, generally if you are using anything, for example, I am taking one small example of a computer, and I want to buy a computer. I am having i3 processor and 4 GB RAM, for example, and one side I am having i5 processor and 8 GB RAM. So I want the computer with low cost, then I will go to this one. If you go to low cost, what happens? It will be slow because the configuration is very light. i3 processor and 4 GB. But if I want Performance is high. If I want to get the performance, I need the performance. I don't bother about the cost. Then better go for what? Performance. When I am going for performance, then what happens? Main requirement of computer is what? Performance should be high. If performance is high, automatically tasks will be completed fastly. Task will complete fastly. So what we require? I require performance only. When we compare with slow, that means what? I require fastest processing. If I want to do fastest processing, I have to go to high configuration, or we can say it as a what? Performance should be high. In the same way, if we come to the concept of generators, generator is going to have what? 1 minute. Okay. Generator is going to have, please, 1 minute. Okay, right. So here generator is, performance of generator is very high when compared to others. Performance is high. So I want to show you how we can say that the generator is having a high performance. Just I want to take one small example, not small example, a large example I want to show you so that you can understand clearly about why I have to use a generator. So see, I am going to take one small program on program. So here I am taking on random module. After completing the concept of these generators, I will go to the concept of modules only. There you can understand what is meant by import, what is meant by these two also. So first I will write the program. I'm going to take names here, list of names I'm going to take. For example, okay, I have taken 4 names. So now I want to take the courses what they are learning. For example, let us take subjects. Subjects equal to, I will write some 3 or 4 subjects. One is learning C language, another one is learning C++, one more person is learning Java, and one more person is learning Python. Okay, right. Now my concept is I want to store the people here. How many are there? 4 students are there. I want to store these 4 students multiple times. Okay, I will explain the code. So here first I want to take what? I want to take one function. Just I want to write that function name is, for a list I am going to write this function. So for people I am going to write people underscore list. I am using a list concept in this function. So how many number of people you want? People I am going to write. Just the concept is what? I want to show you the performance of list, and I want to show you the performance of generator. Why here I am going to consider list only? Is it compulsory to compare generator with a list? No, it is not compulsory to compare with a list only, but generally used collection is nothing but whenever you want to store a group of elements, generally we will use a list. So that I am comparing with this list. So here what I want to do, I want to store the results in a list. Okay, and I want to store some person equal to person details I want to store. So there I am going to write some ID. Some ID I am going to write in a I value I am going to take. 1 minute. For loop I have to write for I in range of how many people we are going to send to number of people, those many people I want to write something. Okay, observe carefully, this is very important point too. So ID equal to I, and I want to do some other thing. I don't want to write remaining things, just I want to do this one. But if I want to write exact program, the program will be very high. So just I am going to stop up to here. Now results dot append of, I am going to append this one person. Okay, that means what? This data I am going to append to the results. Now observe here internally, whatever the operation that is going to be done, I am not going to show you. What I am going to show you means the data that is going to be stored in result. That means the data that is going to be added in results. How much time it is going to take, I want to show you now. Just I will show you the timings also. Okay, right. Now finally I want to return results from this one. That means the program main intention is to store some data into results. After storing that results, I want to send it to the caller. Okay, this is one program. After that, I want to I want to create one more function where I am using the concept of generators. So this is for generators. So I am going to write people underscore generators. Here also same concept I will apply. That is num underscore that is what people, number of people I am going to take. Right now same thing I will write, but here I am going to use yield. So as I am not using this random, okay, I will not use this one. So here I will take same thing for okay for I in range of num underscore people. I want to store in what, inside a generator object. So here person equal to okay, same thing I want to store, but every time what I have to use, I want to use a yield. Yield means what? One person is going to be stored, I will return it. One second person is going to the data of second person is stored. Next I want to throw it to the user. Next third one, fourth one, fifth one. Individually the data is going to be sent to the caller. Okay, but here what happens after completing all the things, it is going to return. So I will show you the time. Okay, yield I am going to write what, yield person. So this is the program I want to show you. So this is the concept. Main concept is what I am taking some subjects. Again here this is not used in my program. Anyway, I thought of using these names and subjects in my program, but I have not used. Anyway, the concept is here. I want to store something into a list here and something into a, I want to throw something that is inside a person. How many values I want to I require 1 lakh people data. So here what happens after completing 1 lakh only, this function is going to throw that is return that values. But here what happens, first student inserted the data, so it is going to return. Second person inserted the data, that data is going to be return. So I want to show you the time, how much time it is going to take to print one value from that list or from this generator. So first to show you the time, just I will take some time module is there, time dot time. That means what, is going to give me some time. Okay, at this time, at this point, what is the time it is going to calculate. After that I am going to perform some operation, that is what, people equal to, I am calling people dot list, people underscore list I am calling. So by passing how many values, by passing so many values. So if I pass these many values, time will be very high. Anyway, first I will pass some values, little values, very less values. Later I will pass more values, so that you can understand the difference. How much time it is going to be taken by the list and how much time it is going to be taken by the generator. So if generator takes less time, I will go to generators. If a list is going to take less time, I will use list only. I can say that when compared to generator and list, I can say what, if list is taking less time, list is great in the concept of performance, in the view of performance. If generator is going to get low time to perform the task, I will go to generator only. Reason is what, it is very fast. Okay, I will show you the timings also here. So now I want to, okay, my task is completed. I want to store the time. I want to save the time what it is now. Okay, completed, time is stored here. So if I perform t2 minus t1, I will get what, total time taken. So print of time taken by list. Okay, just I will do what, I am going to perform t2 minus t1, t2 minus t1. This is for what, this is for list. Same thing I want to perform for what, I want to perform for generator also. So just I will change these variables t3 and t4. You can keep it same also, no problem, but not to make thing complex, I am going to write t4 minus t3. Here what I have to call, which method I have to call here, I have to call generator function, I have to call here. Okay, so this is the concept. Now see here, time taken by generator, I will write generator. Okay, If I'm going to execute this one, see, observe that list is going to take some 0.0002 and time taken by generator is what? 0.0. So first I will explain the program, what is going to be happened here, and later I will show you the output by taking number of values. So if you observe this one, see here, whenever I'm coming here, I'm going to pass what? 1000 to this one. Okay, 1000. Here results is empty. So for I in range of 1000, that means what? This particular for loop is going to be executed for 0 to 999 times. So what I'm doing, I am going to store person equal to some ID and first one 0, so on. It is going to append. How many values it is going to append? 1000 values it is going to append. After appending these 1000 values, what happens? This return results will be done. That means the time is very high when compared to this one. Now let us call this one here generator of 1000. So here how many values are there? 1000. Here also same thing that is going to be done. But here what? Yield of person. That means when this yield of person is going to be executed, every time first it will come here. First for first value, second value, third value, fourth value, and so on. For every value it is going to send the data. So now you can understand, if I change the value of this number of people I am having here, observe now. Here I am taking some 10,000. So just I will increase one value so that you can see the differences in the time. So see, it is what? 0.01. It is what? 0.03 less. Now one more zero I will increase here. Here also one more zero I will increase. So gradually time is going to be increased here. Observe carefully. It is 0.06. It is 0.01. Okay. Now we are going to see the performance of the generator when compared to the list. So here I am taking starting time, and after completing the process, it will note the T2 is noting the end time. After that, here I am going to, if I minus T2 minus T1, we are going to get total time taken. Right, now observe. See what is it is taking. So see, here we can clearly observe that list is taking 0.8, it is taking 0.1. So better go for generators only. Right. Next point, I want to tell you one next advantage, that is what? The advantage is we can take multiple generators. Okay, for what? For performing the pipeline of operations. What is meant by pipeline? Just I will explain that concept. Now, see, I want to perform A plus B into C. So to perform this one, what I have to do? First, A directly it will be considered up to here. When I need the value of A here, after performing B into C. First thing, 1 minute, I will clearly explain how the thing goes. So first I have to take A and B and C. First I am going to perform these things. So first B will be B value, for example, it is 3. 3 will be stored in this one, and 4, for example, C value. C will be stored here until that A is not going to have anything. After that I am going to perform some 3 into 4 here. Okay. Now what I require? I require A value, so that now A value is going to become here. Now 3 into 2 plus, let us consider A value as 4. Now what happens? 4 plus 12 is going to be done, and finally we are going to get answer as 16. This is the concept of pipelining. So here, without getting this, I cannot do the entire operation. Here, how I am going to divide the entire operation into? I am going to divide entire operation into multiple sub operations, and I am performing individual. First I will perform first operation. After that, the output of that first operation is required for another operation, that is A plus. So that first I will perform this one. The output of this one is linked for second input. So for this operation, so that after completing this operation, we are giving the output of this operation to second operation. So anyway, just I will write a small program for this one. Right. So I think you understand about the performance. Now I will take two functions, or let us take three functions. I think already I have shown you this example, that is all even. That means I want to perform what? Even number sum. Okay, just I will take n equal to 0. My concept is I want to take sum of squares of even numbers. Sum of, for some, some sum of squares. For square I have to take one function. For even numbers I have to take one more function. Okay, so here I am going to write while true I will write. That means every time it will execute yield n. I will write yield n. Next, I am going to perform n plus equal to 2. Okay. Next, I want to find even. Define even of whatever the numbers I am passing here. For that numbers, I want to check. For I in range of, that means here range I am going to pass. If I pass 10, it will check up to 0 to 9 and it has to give the only even numbers. So to find the even number, I have to follow I percentile 2 equal to 0. So if it is the thing, I have to pass what? Yield. Yield I. Okay, that means what? It is whenever the number is yield, at that time I am going to send it. Okay, define. I want to use square. Square of nums. I am going to take here and for num in nums. Okay, right. Here yield of what I have to yield? Square. Num into, that is what? Square, no? N square. This is the expression I have to write for square. Now just I will call only with one statement. So here, as I have not used all events, so I will not use this one. Just I will use print of. What I have to tell me here? I want to call two things. First one is what? After performing even numbers, we have to get what? Square. After performing square, I should get the result. So I want to perform sum. What sum I want to perform? I want to perform the sum of squares. Okay, squares, SQUARE, squares, let us write S here. Okay, squares of which numbers? Only even numbers. For even number, I have written one more method. For even method, up to which numbers? 10 numbers, for example. Okay, this is the concept. Okay, observe clearly here. Here, what I am doing means I want to show you the concept of pipeline of series of operations. Okay, that means pipelining a series of operations here. So first what I am doing, I am calling, so the sum is for what? Sum is a inbuilt function that is going to perform sum of the numbers that I am passing here. So first what happens? Squares of even of 10. So first which one is going to be executed? Even of 10. That means it will go here. After performing even operation only, that input has to be given to squares. After performing squares only, that input has to be given to sum. So already I have shown you a plus b into c. After performing b into c only, that value has to be given to a. Then only it is going to perform a plus b into c. Alright, that is the concept. Now observe here. First I am going to call even of 10. Nums value is what? 10. So range of 10. The values will be taken from 0 to 9. So I percentile 2 equal to 0. That means first is what? 0 percentile 2 equal to 0. Yes, it is valid. So yield of I. That means the value yield of I means what? I value is 0 here. First it will pass to this one. Next it will call what? Squares of 0. So squares of 0 means find, that is what it will execute only for 0. Those 0 square will be executed. Next call 1. The condition is fails. So it will not come here. Next value 2. So the value will come here. Squares will be performed. And 3, it will not perform. Only for even numbers it is going to perform. So after completing these two methods, what is going to be happen? Squares of all even numbers below 10 is going to be collected. For that, we are going to perform the sum. First which operation? Even operation. After that, squares operation. After that, sum operation. So right, if I execute this one, we are going to get answer as what? Sum of squares of even numbers below 10. That is what? 10, 120. Okay. Let us take only small number up to 5 I will take. Okay. So that means what? 2 square, 0 square plus 2 square plus 4 square we are going to get. 4 square is 16, 2 square is 4. So we have to get answer as what? 20. So we got it. So in this example, what we have to understand here, first one function is going to take the output of another function and sum is going to take output of squares. Okay, this is the concept of pipelining a series of operations. Okay. Next, last two advantages are, so till now we have seen what? 4. Fifth advantage is it is best suitable for acquiring the or retrieving the data from a large files. Whenever you want to take the data from large files, and if you want to print that data, then better go for what? These generators. And whenever we are going for web scraping means it is nothing but we are going to get, for example, in our for example, I will take one small site, Facebook. So in this Facebook, I want to get the names. For example, I want to get a name in my Facebook, Shiva. How many Shivas are there? I want to get from my Facebook. Then I have to go for a web scraping. That means from web page, I want to take some data. So in this concept also, better use the concept of generators. So it will be very fast. Okay. So these are the advantages of our generators. So just I will briefly show you what are the advantages. It is easy to implement. First one is what? Easy to implement. Next, when we are going to the concept of memory, so memory utilization is what? Very high. Memory utilization is high. Memory utilization is high. Next, third one, that is performance. Performance is what? Performance will be improved, or we can say performance is high. Performance is high. Next, fourth example, if we want to perform the pipelining a series of operations, we can go for this one. That is, multiple generators can be used for what? For performing a pipeline of operations, to pipeline a series of operations. Okay, right. Next one, fifth one is what? If we want to retrieve the data from a large files, otherwise we cannot here, it is best suitable for reading the data from large files. Okay, right. Next, if we want to get the data from web, then I have to go for web scraping concept. So whenever you want to retrieve the data from web pages, then I have to use the concept of web scraping. In this, better go for generators. If you're going for web scraping, there to retrieve the data, we have to go for generators. Okay, thank you.